So my name is Simon Hood. I'm the head of Research IT, the infrastructure half of Research IT in IT services at the University of Manchester. I'm sure many of you know my colleague Rob Haynes, who runs the other half, the software engineering side. So what do I do, or what does my team do? By way of introduction, my team look after all sorts of things. We do everything that is specialist platforms, infrastructure, services. So obviously we do the compute stuff, high performance computing, high throughput. We look after the research data storage platform. We've got a dedicated research VM farm. More recently, we're looking after the University Data Safe Haven, which is very small at the moment, but will be bigger in a year or two's time, for highly restricted data, such as patient identifiable data. We deal with research field support, that is to say, we get out and about on campus and look after bits of weird and wonderful IT that are connected to, I don't know, electron microscopes, patient imaging kit. And more recently, we're doing the cloudy stuff, which is what I'm here to talk about today. So three bits of today. One, to tell you what we're actually doing or have done in the cloud at Manchester. To encourage, and I've got three projects in mind, some collaboration between Manchester and other people, and I know Sheffield are interested, and I know Lancaster are interested, so I'll be obviously going around bullying the rest of you. And then to tell you about what we're hoping to do for the next year, which you might think of as fantasy. It does look a bit hopeful, but I'm confident we can do it. There are lots of arguments going on at Manchester. And a lot of people, including myself, are a bit conflicted because you can kind of see both arguments. The cloud is absolutely fabulous. First of all, you don't have to look after any bloody hardware, which always goes wrong. You can scale up and down as if by magic. You can get things on demand in 5 minutes' time. And by far the most fun bit, when Peter Green phones me up from Dell and sends me a quote, like, oh no, it's far too expensive. I could do it much cheaper on Amazon. I love that bit. And it does work, because you can give him figures to prove it. On the other hand, contradicting myself completely, the cloud can also be staggeringly expensive. Well, I'm sure we've all heard stories of people who've left things running by mistake, and they get a big credit card bill at the end of the month. Oh dear. And as we have found, there is a never-ending series of gotchas. It ain't as easy as it's supposed to be. At Manchester, we have a cloud-first policy from our CIO, which means I have to justify really, really hard with numbers anything that is not moving to the cloud. Default position, you move it to Azure. My response is that my part of Research IT will go paddling in Amazon and Azure, anywhere else. We will try things out. We will get facts, not the results of a pub conversation. We will get facts. We will actually run production services in the cloud for a year and see what happens. I will take the results, I will go to our CIO and say, this bit, cloud, yes, this bit, don't even think about it. That's the plan anyway. It's working so far. So I've got 5 examples for you today. Some of which are great successes, some of which not so much. So, first of all, the great success. Okay, so we've had a Condor pool on campus for some years. Primarily at Manchester, we run it on our teaching cluster PCs. They run Windows mostly in the day. They're used for standard kinds of teaching. At night and at weekends and in the holidays, they reboot into Linux, they run Condor, and they form, roughly speaking, a 3,000 core compute cluster, backed up by about 1,000 cores, mostly of repurposed servers that I've scrounged from various places, which are on all the time. It is a natural model to burst into the cloud, because it's a distributed compute system. So we talked to the nice guys from Amazon, and they said, oh, you should use this thing called Annex. Be trivial, press a button, it all just works. The plan was, anything that's waiting for more than about 20 minutes in the queue in our Condor system, well, we'll spin up a load of stuff in Amazon, everything will just trundle off to Dublin or to Virginia or wherever, it'll run, we'll get the results back. Obviously it wasn't quite like that. Chris Paul, who we had mentioned, spent a considerable amount of effort on this. He's our pretty much remaining Condor expert, who's in my team anyway, obviously he is still around. It would be rude of me to say he completely rewrote the thing, but he rewrote an awful lot of it. Here's a summary of the problems we had. Jobs running twice, because as you can probably guess, you spin up instances in Amazon, and then you want them to join your Condor pool. It takes a few minutes. Well, in that time, your job could have started running locally. Oops. You want to make sure things run in the right place. You don't want a low-memory job running in an expensive 64 gig instance in Amazon. Most importantly, you try and spin up 1,000 instances in Amazon, it doesn't work. We're using the API as Ant is built on. Problem is, if you hit the Amazon API with an awful lot of queries fairly quickly, it puts up the blockers and says, no, you're doing something wicked, pushes you away. It's got a query limit, and the harder you push it, the harder it pushes back. So spinning up 1,000 or 2,000 VMs is not a trivial thing to do via the API. You have to actually be patient, shall we say. So we had to rewrite the scripts. We've included various staggered delays and loops for exception handling. Finally, we've got it working. More to the point, Chris Paul has got it working, so house points to him. And we've got it working to the extent that we can now regularly exhaust AWS region spot market. But it is working. We have stuff running on it. My team, Research IT, Research Infrastructure, have got involved in teaching and learning at Manchester. In particular, a course with that title, AI, Robot Overlord, Replacement or Colleague. Fabulous title. And when you get the slides, you can follow that link for a YouTube video introducing the course. Fundamentally, they just want to run a load of Jupyter notebooks. Most of the time, obviously, they don't need anything. When the course is running, they need 100 or 200 or 300. So it's an absolutely perfect fit for the cloud. Most of the time, you need this much. When the course is running, you need that much. It was relatively easy to get set up. Jupyter Hub, Docker, Kubernetes to scale things up. We copied what they'd done on site on a physical box, but it did need to be re-engineered for the scaling. Because quite obviously, you don't want to be using resources in the cloud. Sorry, you don't want to be charged for resources in the cloud that you're not using. So that's one important point. If you're taking services from on-site, moving them to the cloud, chances are you've got to redesign it and rebuild it. Underline, teaching and learning, perfect example of the cloud, much better than many research cases. Those of you that have tried the cloud probably got a few free cycles from Azure or Amazon. Or maybe you got your personal credit card out, stuck it in the website and played with it for a few hours. Maybe you got a bill at the end of the month you weren't expecting. So our CIO says you must use the cloud. So I say, right, I'm happy to go and play in it. How do I buy the resources? We don't have a route to market. So believe it or not, we started using Amazon by using the IT services credit card with its £1,000 a month limit on it, which we obviously sorted immediately. And that was headache number one. How do I get the limit raised on a temporary basis so we don't get blacklisted by Amazon? Okay, then we got rescued by our procurement office, who are actually very helpful. They found a reseller, bluntly, Arcus Global, that we could use. It worked. You didn't have to use a credit card anymore. On Thursday, I got an email saying that finally our lawyers and their lawyers had agreed the terms and conditions. So we can actually buy stuff from Amazon directly now. And I know some other universities are working on the same thing. Liverpool, I think, amongst other things. So we'd be more than happy to share, get our lawyers in touch with your lawyers so that you don't solve the same problems twice. We now have a service where we can invite researchers into our Amazon organisation. They can use stuff at the end of the month. We will get a line item on our invoice. We can charge it straight back to their research R code or whatever other account they've given us. Just works now. Took a bit of work, but we got there in the end. It means almost certainly I go back to my CIO and say, look, we can move some compute workloads, stuff that's good, for example, on Condor, into Amazon. It makes perfect sense. Other stuff, almost certainly, is just never going to work, at least as things stand with their network. People are enthusiastic about the cloud, and I am. Always mention all those hidden costs for your on-site hardware when you're trying to compare the cost of running your HPC cluster to the cost of running in Amazon or Azure or Google or what have you. That's absolutely true. There's also lots of hidden costs, as it turns out, from moving existing services based on boxes and data centers to the cloud. And we've had all sorts of fun at Manchester. As I said, our CIO, big fan of the cloud, and he wants to move a great deal of our enterprise services, or our Oracle-based stuff, for example, payroll, important things like that, into the cloud. We're doing it. It's proving a complete headache. It's proving very costly. The actual cost of buying cycles, not buying cycles, the cost of setting it all up, getting the legal stuff arranged, that's been horrendous. I've kind of mentioned that already. The cost of spinning up proper enterprise frameworks in the cloud, not just moving a toy system over there with a little website or a little cluster that's there for 10 minutes. Real enterprise frameworks that have got to be there 24/7, 365, otherwise the finance system falls over. Otherwise you don't get paid. That's much more expensive. Getting all your local authentication and authorization to work in the cloud, that's got to be done. You've got to check all your software licensing. I don't know how many applications we've got on a local HPC cluster, 150, 200, something like that. We've got to check the license of every single one. And some of them, you look at them and you need a lawyer, definitely. You've got to train your users, you've got to train your own sysadmin staff. And you've got to speak to your information governance people who are going to be very upset that you're moving anything to the cloud at all. It's an expensive business. I'd be willing to bet if you add that up, you could build your own data center. Do that for probably £1 million. If you're running a server on site and you're hammering it, you can't get the network connectivity to work. Well, you've got a few Cisco switches and you're there. Easy to diagnose. Go and find your friend in the network team, sit down, sort it out. If you're hitting Amazon hard and the network connections stop working, what's the problem? Who knows? Is it your on-site Cisco switches? Is it the campus universal threat management boxes, i.e. fancy dynamic firewalls? Is it the Janet network? Is it some commercial network? Is it the cloud own threat management? Is it the cloud internal network? Who knows? That's a really hard thing to figure out. Cloud is fantastic, but there's lots of technical issues, lots of financial issues, lots of legal issues to go use it.